Hi, my name's Daryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. I'd like to take a few minutes and introduce you to a new product that we've been working on. We're really excited about them. These are 5,000 ohm strain gauges for stress analysis testing. If we look at this part number, we'll see this particular one is a C5K-06-125LK-50C. And that basically means that it's a small linear strain gauge that's a 5,000 ohm resistance. So you might be thinking to yourself, why would I ever choose a 5,000 ohm strain gauge? I've been using 120s or 350 ohm gauges in my lab, and why would I make that choice? So I'd like to talk about a couple of the advantages of using 5,000 ohm gauges. The first one is gauge factor desensitization. Gauge factor desensitization is basically the influence of the lead wires in the measurement. Anytime that you add lead wire resistance into a strain gauge measurement, you can think of it as resistance that's present that's not strain sensitive. And when that's the case, it's going to desensitize that strain gauge, meaning that it'll produce a lower response. Well, if we go to these 5,000 ohm strain gauges and you look at that ratio between the lead wire resistance and the 5,000 ohms, I think you'll find that the majority of stress analysis applications, basically that lead wire resistance is now negligible, or it has a negligible effect on the overall measurement because that ratio now, the resistance to that lead wire is so broad. Secondly, if you're using a battery operated instrument, you'd find that your batteries would last much longer. You could do the current draw calculations and estimate how much longer. But basically, if you're using battery powered equipment, maybe telemetry systems or some type of device that's remote, that's using standard batteries to power it, you might want to consider going to the 5,000 ohm strain gauges because your batteries are going to last a whole lot longer and you don't have to go out in the field and replace them nearly as often. Next, going to the 5,000 ohm strain gauge allows us to excite the bridge with a higher voltage. By exciting the bridge with a higher voltage, that means we're going to get more signal out of the Wheatstone bridge, and more signal means potentially a better signal to noise ratio. So if you're battling a noise problem and you're looking for ways to try to at least minimize its impact, you might want to consider going to a 5,000 ohm strain gauge because you'll find that if you can increase that voltage, if your instrument allows you to do it, then you're directly going to increase that signal out, and potentially that allows you to use less gain. And then lastly, if you're testing plastics and composites, one of the common issues with testing plastics and composites is a phenomenon called self-heating. Self-heating simply means that you start to put too much voltage into the strain gauge and it starts to become unstable because it can't dissipate the heat quickly enough. Well, in this case, now you've got a 5,000 ohm strain gauge that will dramatically reduce the amount of current that's flowing through that gauge, and it's really that current that produces the heat. So basically, if you're testing plastics or composites or ceramics or other materials that aren't good heat sinks, you might want to consider the 5,000 ohm strain gauge for that reason. Now, if you'd like to find out more about these 5,000 ohm strain gauges or just have strain gauge questions in general, please feel free to reach out to us. You can contact us through the website at www.micro-measurements.com or pick up the phone and call us at 919-365-3800 and then just follow the prompts to Applications Engineering. Thank you and have a good day.